Hi viewers, welcome to HVAC Simplified. Today's topic of the day is psychrometric chart and properties of air. We are going to understand in the first part the psychrometric properties of air, part 2 psychrometric chart, part 3 relationship of air and temperature. We are going to see in details part 1, part 2 and part 3. So let us begin with the first part, psychrometric properties of air. The first property of air is dry bulb temperature, wet bulb temperature, dew point temperature, relative humidity, humidity ratio, enthalpy, specific volume, vapor pressure. So let us understand all these properties in detail. Dry bulb temperature. A dry bulb temperature are read from any ordinary thermometer that has a dry bulb. Wet bulb temperature. Wet bulb temperatures are read from any ordinary thermometer whose bulb is covered by a wet wick. The difference between the wet bulb and the dry bulb temperature is caused by the cooling effect produced by the evaporation of moisture from the wick. The evaporation effects reduce the temperature of the wet bulb. This will be the same ordinary dry bulb thermometer to which the wet wick will be added and the temperature will be recorded. The temperature due to evaporation of the moisture from the wet wick will be known as wet bulb temperature. Dew point temperature. The third property, dew point temperature, is the temperature at which the moisture leaves the air and condensates on object, just as the dew forms on the plant. We will be understanding the dew point temperature in detail in the further slides. So, in simple words, the dew point temperature is the temperature when the water droplet starts condensating from it, which means the air can no longer hold the moisture in it. We will understand why does it happen. Relative humidity. The fourth property, relative humidity, is the comparison of the amount of moisture that at a given amount of air is holding to the amount of moisture that the same amount of air can hold. Relative humidity is the terminology used in percentage to identify the amount of percentage of moisture in the air. So relative humidity is equals to amount of moisture that at a given amount of air is holding, amount of moisture that a given amount of air can hold. So at a particular temperature, what is amount of air is holding by what amount of air it can hold. Relative humidity 50%, relative humidity 100% is known as saturated, where it cannot hold any further moisture content in it. Relative humidity is expressed as a percentage. For example, if the relative humidity of the air is 50%, it contains half the amount of moisture possible at the existing dry bulb temperature. So now let us understand the relative humidity with few examples. Let's suppose there is a glass of 100 milligram which is not filled with water. So the glass of 100 milligram supposed to be the dry bulb and the water which is empty is supposed to be the wet bulb. Let us assume the same example with a room which is 100 milligram of space which is holding zero amount of water in it. So the total amount of water or the space it can hold is 100 milligram. Now by using the relative humidity formula, actual moisture by moisture can hold. So 0 ml by 100 ml. By this equation we can say that at this particular scenario the relative humidity is 0 as it's not holding any amount of moisture in it. Let's see the second example of 100 milligram glass holding a 25 milligram of water, or a 100 milligram of room holding a 25 milligram of water in. Now by using the same relative humidity formula, we can say that at this particular scenario the relative humidity is 25%. Let's see the third example with 75% of water is holding in 100 milligram of water. Same with the room. Now by using the same formula again, we can say in this particular scenario the relative humidity is 75%. So the amount of moisture it can hold is still 25%. Now let us see the same example with 100 milligram of glass is completely filled with 100 milligram of water, and the room of 100 milligram is completely filled with 100 milligram of water. Now using the same relative humidity formula equation again, at this particular scenario we can say at this time the relative humidity is 100%. Yes. Now by assuming this particular scenario, you can say that the relative humidity is holding 100% of moisture in it, and it cannot hold any further moisture content in it. This is where the common scenario where the dry bulb temperature and the wet bulb temperature has to be same, and at that particular temperature the air cannot hold further moisture in it, and the water droplet starts falling from it. So now you can see clearly that scenario 1, scenario 2, scenario 3 and scenario 4. Humidity ratio, which is also known as absolute humidity. The humidity ratio is referred as a moisture content or the mixing ratio. It is the mass of water vapor per unit of mass of dry air. The ratio between the actual mass of the water vapor present in the moist air to the mass of the dry air. Humidity ratio is normally expressed in kilograms or pounds of water vapor per kilogram or pounds of dry air, where X is equals to mW by MA, where X is equals to humidity ratio and mW is the mass of the water vapor at a given temperature, and MA is equals to mass of the dry air at the given temperature. So at any given temperature, air has got its mass and the water vapor has also got its mass. Enthalpy. The actual amount of heat in the air is referred as enthalpy. Enthalpy is measured of heat energy in air due to sensible and latent. So let us assume sensible is equal to the temperature of the air. Latent is equals to the moisture in the air. So sensible is considered as the dry bulb as an assumption, and latent is an assumption considered to be as the moisture. The enthalpy is measured in IP units, BTU per pound of air, or SI units, kilojoules per kilo kg. Specific volume. The specific volume of air is the certain weight it occupies under specific conditions. The specific volume is measured in IP units and SI units, where in IP units it is measured in cubic feet per LB, and in SI unit it is measured in cubic feet meter kg. The specific volume is the volume of the air at any given temperature. So we are talking about here the dry bulb temperature. So any dry bulb temperature at any given temperature has got its own specific volume to hold the moisture content in it. Remember one thing, that the lower the dry bulb temperature, the lower the specific volume. The higher the dry bulb temperature, it can hold the most moisture content in it, because the specific volume of the higher temperature will always be more. Vapor pressure. Vapor pressure relates to the number of water vapor molecules per cubic meter and related to absolute humidity. Vapor pressure affects the evaporation rates. So when the humidity is high, the vapor pressure is high, which results in very little evaporation in humid climates. Vapor pressure is measured in IP units, in inches of mercury, in SI units, in mm of mercury. End of part 1.